Apt.
And so it is. Welcome to Classes and Objects. I'll be your host, Kyle Coberly, and let's talk about classes and objects. So, brain dump. I would like you to Slack me everything you know about classes and objects. If that's nothing, completely fine. If like blueprint's all you remember, that's fine. If you've been following along in some of the labs, I want to get an idea of what I'm working with here. So I'm going to put a couple minutes on the clock, write down everything you know, and send it over to me. Go.
Do you want that in a private message?
Yes, please.
A direct message? Okay.
All right, whatever you're working on, send it over to me. I think I still see two of you typing. Thank you, Sam. Okay, cool. Thank you very much. Gives me an idea of about where we're at on this. So let's see if we can't make those answers a little bit better over the next hour. That's our objective here. So I had said on Tuesday that class is a cookie cutter, object is a cookie. You'll also hear people say, What are metaphors have you guys heard used with classes? There's a couple of them.
I've heard the dogs to owner example a number of times. I don't know if that's exactly a metaphor for it or it's actually an example.
That's like an example of something that we might do with classes and objects, but not classes and objects themselves.
Something about classes being blueprints and objects being interject whatever buildings.
Perfect. Blueprints and buildings is great. What else? I'm going to throw out shape. Fuck, I don't even know what the specific of that would be. I call this an abstract shape and a concrete shape. So the shape might be a triangle. The concrete shape might be an equilateral triangle where each side is 2 inches long. So these are classes. These are objects. I want to give us another way that we can think of these.
I guess you can think of the class as like a factory, like a car factory, and then you're manufacturing a different car, and each car is kind of like an object that represents some property or method from that factory.
Oh, that's pretty good. So,
Would that extend to just like car brands and their individual models that they roll out? Like a make and a model?
so I'm going to say Nissan Altima is the class, and my Nissan Altima is an object. So Nissan Altimas all have a similar shape to them. They have the same blueprint, but my Nissan Altima isn't literally the same thing as your Nissan Altima, as every Nissan Altima. They're different colors. Some of them are on the road right now. Some of them are in garages. Some of them have been sold. Some of them haven't. So there's some differences between actual Nissan Altimas, even though they have a lot of the same things in common. All right, I'm going to give you another way to think of this. This is talk about state and behavior. Let's stick with cars for a second. So what are some states that a car can be in?
Moving, still, wrecked, pristine.
So I could say like, is moving, has been driven, is wrecked. Do you think of any other states that a car can be in?
California.
Nice. Current location.
Working, in need of repair.
Time traveling a la DeLorean.
Needs repair. Current year. Also, how about things like its color?
Or like
Oh,
modified.
yeah, mileage is great. Current mileage. So
Can we think of that as a state, or is that more like an attribute or a property of the car?
Attribute, property, state, all the same thing.
Okay.
So like where it is in its like service cycle.
Sure. So property, attribute, state, all of those things, those are synonymous. These are different states that the car can be in. Car can currently be blue, can be red in the future. So you can say it's an attribute or property of it, and it changes. You can also have state that doesn't change. Number of wheels.
It's make. Yeah.
Sure. Yeah, who manufactured it? We'll say that's part of the state also. Okay, let's talk about behaviors. What kinds of behaviors might we do with a car?
Fast, slow,
Those are states.
drive, park,
Yeah.
crash.
So drive, park. These are things that we're doing with the car. We're driving, we're parking, we're crashing.
Replacing the engine.
Set new engine. And maybe like we give that an engine. So that would imply too that there's a state that's something like current engine. And then we use this behavior to change what the current engine is with whatever we pass in there. What other behaviors?
Hey, Kyle,
Yep.
are you supposed to be sharing your screen right
Oh
now?
my good fucking
Man, I
gravy.
was so close to asking.
I was going to ask that in the chat.
It looks like you were writing something that we should have been seeing, and I was like, I don't know.
The
You got-
triangle thing was where I started
Yeah.
to suspect.
Good God. All right, so this is day 3 for you guys. I'm going to do that about every day of your entire program, just a heads up. So here's what you missed. There's cookie cutters and cookies and blueprints and abstract shapes.
All I have is your Slack.
This is Slack.
Yeah,
Oh,
Slack too.
With your extremely private messages to Gerald.
yes. So
Nothing personal in there, though.
I do that less often. I do that about every other day. Hey, there we go.
Ooh.
Beautiful.
Nice.
There we go. There was our classes and objects. Those are our metaphors. Here's our states. Here's our behaviors. So we could set a new engine, we pass in an engine, and then this state changes. What other examples can you think of car behaviors?
Clarifying question. If a state is parked and the
Yep.
behavior is park,
Yes.
is it like the act of parking?
Yes.
Okay.
And so we would expect that to change the state from is parked false to is parked true.
Okay.
Any other behaviors you can think of?
Any like internal functions like the radio,
Sure.
like that, blinker lights.
Turn radio, and then you could even pass in a state, on or off. Yeah, any of those things are behaviors. Not every time, but most of the time, when we're using a behavior, we're trying to change a state or read a state or do something with a state. All right, one last thing, then we're going to start getting way more concrete. So you could call this at rest. We can call this in motion. So these states, at some snapshot in time, these have some fixed thing that they are or aren't, right? These behaviors generally take us to new states. So those are in motion. At any given point in time, we can tell what the state of an object is. And then we use some behavior which may or may not change the state of it.
So behavior, I mean, I guess in the sense of like a computer program is probably a fraction of a second, and then a state is static.
Yes.
We
exactly.
crashed in a second, and now the car is wrecked.
Correct. We were in the not crash state. We called the crash behavior, and now the state is crashed. Behaviors are methods, functions, procedures. Just like property, attribute, like those are state, method, function, procedure. These are behavior. So to pull this back to what we were just talking about, the class says, all right, anything you make with this class, any cookie you make with this cookie cutter, any building you make with this blueprint has an is moving state, has an is wrecked state, has a needs repair state. You can also drive it, you can park it, you can crash it. That's the shape of this thing. Now, when you make it with something, your cookie is moving, false. Is wrecked, true. Current location, Denver. That's the object. But anything that was made with this car class can drive. Anything that was made with this car class can park. All right, let's make some stuff. So I would like you to follow along with this, if you'd be so kind. I want you to make a new folder, and we're going to call it car classes. So mkdir car-classes. And then you're going to cd into this car classes folder. You're going to make an empty file called car, capital C, .rb. And you're going to touch a file called environment.rb. Do all those things. I'll give you a sec to catch up. You'll know you did this right if you can run ls and see those two files come back.
Is there a reason you capitalize car and not environment?
Yes, because car is going to be a class. And by convention, it's actually a rule in Ruby, but it's not in every language. It's a convention most places. Our class names start with capital letters, and our object names and file names and most other things don't. So if I see something that starts with a capital letter, I'm assuming it's a class. All right. Now I want you to open up your environment file in a text editor. And we're going to include that car file. Who can tell me how we do that?
Required quote car.rb.
Ooh, almost.
I guess slash dot slash. Since
Dot slash. So if it's my code, dot slash. If it's somebody else's code, no dot slash. So I also want to pry in this. So how do I include pry? Require pry. Not my code. No dot slash. Also, I put parentheses here, or yeah, parentheses. Just like, oh, what can you infer from that? I could do that, or I could do that. What does it tell us about require?
It's a method.
It's a method. It follows our normal method rules in Ruby. All right, so I'm requiring pry. I'm requiring my car RB. Also, pro tip, you don't need the RB. The only things you can require are Ruby files. So if you leave off that extension, it'll figure it out. So that's how you'll usually see that. And then I want a binding.pry at the end. So you'll know that this worked if we can call this environment file with Ruby and get into pry. So I should be able to Ruby environment RB and see something like that. And then you can get out of that pry with a control D. All right, give me some kind of visual confirmation that like you're tracking on this. Give me a thumbs up if this is working so far.
I've got a question that popped up. I just tried to save it after I typed that in, and I got failed to save car.rb, unable to write file, unknown file, and then it goes off the screen. Oh, read only file.
Tell you what, Matt, why don't you take over the screen and let's work through this all as a group.
Bueno. You see my screen?
I do. Weird. Read-only file system, huh? Show me your text editor.
Show me my text editor.
Or sorry, not your text editor. I mean your terminal. All right. Give me an ls. Okay. Looks good to me. Give me a pwd. Looks good.
Was this command correct when I opened up?
Oh, no, it was not.
Okay.
I see what's going on now. So let's break this down though, because this is really good. So what that says, everybody look where it says code and then dot and then slash car.rb. So what this says is, hey, VS Code, I would like you to open the current folder that I'm in right now. Additionally, I would like you to open a new file called car.rb that's in the root of my entire computer. So if we look over at the open editors thing up there, you have the car classes stuff. That's our stuff that we're working on. This one that you were typing in though, this is in your terminal, go cd space and then slash. Cool. So this is the root of your entire computer. Like this is don't mess around with this shit kind of territory. So give me an ls. Yeah, so this is all of our like top level stuff. That's why you're trying to save that file right now.
Gotcha.
So if you copy the things that you wrote in your car.rb file up in your text editor, and put that in the other car.rb file below it.
Below it.
See how you have like two structures?
Yep. Right here, yep.
Yeah.
Okay.
But if you save that one, it doesn't get so fussy. Hey, there we go.
Does not. So can I just close this other one?
Yes.
Okay, great. Cool. That's fun.
In general, this is anything you see that starts with a slash. It's called an absolute path. It goes all the way up to the top of your computer. Something that starts with a dot starts from where you are right now. Something that starts with a dot dot is one up from where you are right now. And then a tilde is your user home directory. Those are all the symbols. So we use all of those to navigate around through our computer. Starts with the slash, starts with the dot, starts with the dot dot, starts with the tilde. That's it. Cool. Give me a thumbs up if you were able to get into your Pry okay. All right, seeing lots of thumbs up. Daniel, Derek, how you guys doing?
I'm doing all right. Mine opened up in my bachelor code that I was trying to write, so I'm trying to fix that.
Okay, screen share real quick. Let's fix it.
Yeah.
All right. Aha.
So I was trying to follow along, and then I got stuck here.
Okay, so let's see if we can use one of those magic symbols. Do a CD, and then space, and then the tilde, and then slash, practice. Cool. Give me an LS. You're beautiful. All right, so we've got those two files there. Tell you what, go ahead and close your text editor. That's fine. All right, so you've got the Haskell thing there, and you have this car and the environment. Couple things we want to do. So car we want to have with a capital C, and environment has an N in it. So I don't want you to open this up with your like Mac file finder. I can always tell when you did that. I'm not going to be able to. I'm not going to tell you now how I can tell that you guys do that. But we're going to learn how to do this like a programmer. So we want to rename car to car with a capital C, and so we do that with the MV command. So you're going to do MV space, and then type a C, and then tab complete. Oop, lowercase c. And then hit tab. There we go. And now type car with a capital C. .rb. Yep. Fire it off. All right, now run your ls again. Cool. That's how you rename files like a programmer. So do that with environment also. Ooh, almost.
What am I doing here?
Oop, NM.
MN?
NM, environment. Yeah, there we go. Cool. .rb. Very nice. And so we have this in the same folder as Haskell now. We want to put this in its own folder. So what we're going to do is mkdir. And we're going to call this car-classes. Beautiful. So if you do an ls now, you'll see that we have two folders and these two files. We want to put those files in that folder. So what do you think we do?
Compile directory.
Ooh, almost. MV. The exact same command for moving a file and renaming it. So we're going to move car.rb. into car classes. So just hit space and then lowercase c AR and then tab complete it.
What was that?
Just tab complete it. Hit tab. Perfect. Hit tab again and again. There we go. And hit enter. Cool. Now if you ls, we've moved that into that folder. So do the same thing with the environment file. Beautiful. All right, so now we're going to cd into the car classes folder. Tab complete, tab complete.
Oh.
There we go. Awesome. Now do code dot, space dot. Yeah.
Awesome.
You're beautiful. Thank you for like putting yourself out there, letting us all learn something from this. It takes a long time to get used to managing file systems on the command line, but once you do, you'll never go back. So much faster. And then go over to your environment file. Let's just make sure we got the stuff in there. All right, I'm going to screen share again, and you can copy. All right, so, all right, that's what your environment RB should look like. So this is making it so that we can pull in this file, run pry, and do some stuff. So the bare minimum that we can do to make a car class is go into that car folder and type class car with a capital C and then the end keyword. And if we do that, we should be able to run this environment file and make as many cars as we want. If I run Ruby environment RB, I can say my Nissan Altima is car.new. Hey, there's my car. My Ford Fiesta car.new. Hey. So I have these two cars. I can do whatever I want with them. Not much. They don't have any state or any behavior right now, but I can make them. Car is a class. Nissan Altima is an object. Ford Fiesta is an object. Ask me some questions about this.
Did you do something before you did Ruby environment.rb?
No. I added this to the car RB file. My environment looks like this. And if I Ruby environment RB, I can make new cars.
My binding pry is not showing up in my terminal, but I created the environment. But perhaps I missed a step.
Your environment look like this?
Yes, that's what I have. But I'm not getting the binding pry at 3.
All right, go ahead and screen share. Let's work through it.
Okay.
Ah, so what's your environment.rb missing? You've got all the files coming in just fine.
So I have to put binding pry or
Binding.pry. That's what actually triggers the pry.
Oh, I'm sorry. I thought that was populated auto.
Nope.
So just like that?
Just like that. So save that file. I can tell that those files aren't saved because they have those white dots next to them.
Okay.
Oop, use the key command. This is something you're going to be doing like every 20 seconds the rest of your career. There we go. Ooh, what's this other one?
That's what I was wondering.
Well, I went into the terminal and then I opened it as well.
Gotcha. All right, do an ls for me in your terminal. Environment.rb. Environment.rb. You're blowing my mind grapes right now. You can only have, is there a spelling difference between those? Am I just not seeing it?
No, I don't see any variation, no.
Maybe there's a space somewhere in it. Do an ls space -l.
LS space dash L.
-l. Yep, just like that. Oh, that is wild. Because here's the thing. You can, like, names have to be completely unique within a folder.
Yes.
I have no idea how that's happening. All right, so let's do this. Close that file in your text editor.
This one that's open right now?
Yeah, exactly. And then, oh, I'm going to show you a cool trick. So go over to your environment RB file. So let's type it. Let's type these things out again. So it's require pry. And it's a string, so you want to put quotes around it. Very nice. And then we're going to require .car, ./car, sorry, and capital C. Also got to wrap it in quotes. Very nice. There we go. All right, and now let's do the binding.pry.
Okay.
Okay, very nice. Back over to your terminal, save that. Very good. Back over to your terminal. And now press up, enter. All right, so what we want to look at, you have those two environment RB files. There's the timestamp right next to it that shows which one was the last time it was updated. So we want to get rid of the second one. I don't even know how we do that if we can't target it by name. Oh, that's so weird.
Differentiate, yeah.
So, well, let's see. Give me an RM.
RM?
Yep. This is for remove.
Yes.
Space. ENV.
ENB?
V.
Oh, V, sorry.
And then let's try to tab complete.
And then run?
Tab again. I'm just curious. Ah, there it is. I knew it. So that that second one, that little backslash, that's called an escape character. What it's escaping right now is a space. You can't have a space in a file name. And so if you want it to look like it has a space in a file name, you escape the thing after it. Oh, amazing. All right, so hit tab again. Again. There we go. Oh, all right, hit enter. And again. And we're free. Oh, beautiful. Now try doing Ruby environment RB.
Okay.
Tab complete, tab complete, tab complete. There we go.
And then enter, yeah.
Yep. Cannot load such a file pry. All right, who can tell me what we do if we run into an error like this?
Have you loaded pry?
We've got it required in the file. What's the other?
No, has he like installed it? I mean,
yeah. How do we do that?
install.
Install pry.
Gem install pry.
For some reason, I constantly have to do it.
Beautiful. Now press up, up, enter. You're beautiful. Okay, very nice. All right, so
Kyle, I am also getting that I'm not in a learn directory. I feel like I've hit this issue before and I don't remember.
doesn't
what
matter
that
if you're in a learn
is.
directory. We're not doing any learn things.
Okay, so I was trying to run learn to get to my binding.pry. I need to be running the name of the file.
Ruby environment RB. We are off the beaten path. We're just writing commands at this point, baby. No
Bueno.
flat iron hand holding necessary.
You require RSpec and run RSpec that way, I guess.
You can totally do RSpec that way as well.
Is there an advantage to doing RSpec over typing it in the terminal, or terminal over the RSpec?
Doing RSpec versus learn.
Calling the Ruby file in the terminal.
Yes. So learn is like a very specific Flatiron School thing that looks for like test files and will write it back to your learn user account and stuff. We're just writing Ruby like regular Ruby folks, man. We're just Ruby devs now. We're just Rubyan.
Undefined local variable environment.
Ooh. Screen share. Let me see. Cool. So let me take a look at your, probably going to need to reshare. Let me see your terminal, or not your terminal, your text editor. All right. Environment RB, require car, require pry, binding not pry. Let me see your car. Class, car, and I'm a little confused why you're getting the angry squigglies, but yeah, we'll see. Go ahead and save. All right. And then let me see this folder again.
Over here in the...
Yeah. Give me an LS. Oh, you're still in pry. Do a Control D to get out of pry. That's why that was happening. All right, close out that other one with the X. There we go. Control D, not Command D.
Oh, sorry. Yes.
There we go. All right, give me an LS. All right, now do that. Okay, take a look at how your prompt changed. So the thing that said car classes before, you can type Ruby in that. That's your terminal. Right now, you're in pry. So if you try doing Ruby environment RB, it'll go, I don't know what the fuck this Ruby variable you want to use is. I don't know what this environment RB file is. I'm in Ruby land now. So now you can do regular Ruby stuff. You can require stuff. You can make new instances of classes. You can do whatever you want with Ruby. It's different than just your terminal.
Gotcha. So this still won't work here.
But no, you're in it. So try making a new car.
Just what, car?
Sure. Car equals capital C car. Oh, you got it right.
Oh
so
boy.
No. Lowercase c car, that's going to be your object.
Okay.
Equals capital C car, that's your class, dot new.
Whoa.
You're beautiful.
And happy.
Very nice.
Thank you.
Other questions so far?
What was that weird symbol?
Which symbol?
I got the same one on the car RB file. Just in
the little squiggle?
Yeah.
It's like Microsoft Word or any of those things. They're like, you made a spelling error, a grammar error, but
Oh yeah, I have some kind of like style checker.
Rubocop.
Yes, it is Rubocop.
There we go. All right, so we can make new instances of cars. Huzzah. So what I want us to do now is I want us to make some state, and I want us to make a behavior. So when we call that .new, the method that actually gets called is called initialize. It's kind of a confusing story why we wouldn't just do something like this. So take my word for it that it makes sense to do it this way. But when we call .new on some class, it's going to make a new instance of that class, and it's going to call this initialize method. What's kind of cool about that is we can pass things into it. We can pass more than one thing into it. It's just a method. Same thing you've been doing all along. And if we want to, we can save those in instance variables like that. They don't have to be the same name. There's usually not a good reason for them to not be the same name, but that works too. So we have passed in 2 arguments to the initialize method, and we're saving both of them as instance variables. Instance variables are an example of, starts with an S.
Something.
State.
State.
Ah.
There are state. We are setting the state of this car. We're setting its name to whatever name gets passed in. We're setting it to Mach 5. We're setting the state of its driver to Speed Racer. We could change its state at some point so that its driver is Snidely Whiplash. It's a mashup between the Wacky Racers and Speed Racer.
I was trying to place who that was.
With special guest appearance by Muttley. Cool. So that's state. Questions about that?
So the idea of it being name and driver are an instance is because those are impermanent. They could be changed. The state could change at any time.
It's more that I can make another car that's called the Blue Lightning. Come on. And this other car has a totally different state to it. It's owned by the specific instance of the car, not every car. That's why it's an instance variable. Actually, that's a good point. There's no more classes. There's no more objects. COVID knocked them out. This time of pandemic of ours has really taken its toll. Let's say I wanted to do this exact same thing that I did up here without classes and objects. just with the exact same procedural Ruby stuff you guys did in the pre-work that you used on HashKitball, all that kind of stuff. How would I do it?
Just declare variables.
Yeah, give me an example.
Car name Mach 5.
Exactly. And like car driver. Okay, that's fine. Until I have to make this other one. Then I end up doing something like car 1 driver. Then I end up doing something like that. Okay, that gets awkward really quickly. Also, there's nothing that's indicating either to a future developer or to like the programming, to Ruby, that these two variables have anything to do with each other, or that like this name here kind of functions the same as this name. And so that keeps me from doing something that just takes in a car and gets its name or gets its driver. I can't write any programs that do that.
If you put that stuff into a hash, then you could like label each hash instead of car 1, car 2, stuff like that.
Yeah, now we're getting somewhere. So I could do that. Now I'm indicating that these things have a relationship. Now I can pass around these cars and look up the name symbol on them. That gets me halfway there. What can't I do with this?
That still doesn't necessarily imply, if you had a car 2 in the same hash, even with the same keys, it doesn't necessarily imply a relationship.
It doesn't. There's nothing that like enforces that these things are the same shape. That's part of the problem. Because if I try to, I could do something like that and it doesn't throw an error. I want that to throw an error. I want that to be mad at me if I do something like that, because it should be the same.
Because now it's just data.
Right, exactly.
Yeah.
So that gets to the next problem with doing it this way. If it's just data, what are we missing?
The relationships.
Not the relationships.
No.
Behaviors.
The behaviors. Because in this class, I could also do something like is driving false. Now I can do things like car.drive, and that's going to change the state of this one car. Ruby doesn't let me do that kind of thing here. I can't do drive, def, drive, and like syntactically, Ruby doesn't have any way to do that. Coincidentally, JavaScript does. If this was JavaScript, you're goddamn right, that's exactly what I could do. And this is part of what makes the difference between JavaScript and Ruby confusing. This is called a hash in Ruby. You know what it's called in JavaScript?
An object.
An object. And that's why. Because we can put the behavior on those in JavaScript. You can't in Ruby. That's why we have classes and objects.
So is that same kind of through and through with JavaScript? Everything's an object. Is that the same in Ruby?
No. Everything is an object in Ruby. That is absolutely not the case in JavaScript. That phrase gets thrown around a lot. You'll see that in blog posts and stuff, but it's actually not true in JavaScript.
Okay.
JavaScript does actually have primitive values, strings that aren't objects, Booleans that aren't objects. That changes a little bit at runtime through a thing called boxing. And one time I sent Damon down a rabbit hole on that, and he had to like take the rest of the day off. That's the very end of the pool. So I wouldn't worry about that too much.
Yeah, okay, good.
Yeah, every single thing in Ruby is an object. That's actually not the case in JavaScript.
So Kyle, just to reiterate, we have classes and objects in Ruby because we can't put behaviors into just data?
Correct.
Okay, thank you.
And there's some other benefits to that too. Someone nailed on that. That doesn't throw an error. I want it to throw an error. I want this to be predictably the same thing. And if I start using it in a slightly different way, I want it to get grouchy with me. Classes enforce that. Hashes don't. Objects in JavaScript technically don't either.
In your method there on the line above your cursor, one up, you do or don't need to have name and driver on that line?
Who can tell me what name and driver are doing on that line?
Assign a name and driver to this car.
Ooh, that's what happens here. What's happening?
Telling initialize to expect two
Arguments.
inputs to populate for name and driver.
Correct. You're going to get two inputs. Every time somebody makes a new car, you're going to be given a name and a driver. And
okay,
I'm telling you that they're called name and driver right now.
Okay. So you could have a trillion other things in there, but you need at least the things that you define.
Yes. Pro tip. These are called parameters. These are called arguments. Sometimes you'll hear people use those interchangeably, but they're not the same thing. A parameter is when you're defining it. An argument is when you're using it.
So a parameter receives an argument?
A parameter defines what arguments are allowed.
Got it. So, okay.
So you use the parameters to make your argument?
Correct. Or like, if we did this mathy, we would say that X is a parameter, and me like making that concrete. See, 2 equals 2, 1 plus 0. So if I do an actual instance of that, 1 is an argument, X is a parameter. This is the abstract thing. This is the concrete thing.
Classes are abstract.
One last thing. I can set this state here, but I can't read it yet. Why?
It's because it's still a local variable that's defined within that class, so you can't really access that outside of that. Is that kind of the logic?
You're 85% right. So you can't access instance variables, but they're instance variables. That is a local variable. That's an instance variable. They're technically, they both still exist. But yeah, we can't see an object state. That's part of the rules of objects. You cannot directly access an object's state. The only way you can access an object state is through its behavior. So if I want to be able to read the name, I need to make a behavior, I call it whatever I want, and have it return the state. So if I do that, and I say car is car.new speed racer, oops, other way around, Mach 5 speed racer, like that. All right, cool. I can see those on the terminal, but I can't actually do anything with them. If I try to do car.driver, it'll go, I have no idea what that means. If I do car.name, same thing. Car.driver. Because I don't know what that is. If I make it fart, oops. So I make the car, I do car.fart, I can get its name out. Now, conventionally, there's no reason to change the name. We just say that. And now I can do make a new car and then get its name. Name is a behavior there. It happens to be returning the state to me. But this is core objects and classes idea. You don't directly work with state. Use behaviors to get state.
So is it like that so that you don't ever try and change the state? Or like, why would you otherwise not be able to access it?
Because math. There's very good reasons for it. They're not super important right now.
Okay.
Because we can change that. What you do to do that, you make another method called name equals that takes in a name. It's like that. And the way that works. So make our car, hey car, what's your name? Stupid. Name equals Mach 6. And now if I get the car's name, that's what it is. As you might imagine, it's super fucking common to just get something state, to set something state. So we would be writing stuff like this. I mean, just for the ones that we have, that's 6 different methods that we have to write. 3 to read them, 3 to write them. And they have this exact same shape. It's just boilerplate. So adder reader just generates that code for us. Adder writer does the other one. Adder accessor does them both.
So when you use that macro at the beginning of the class, what is name at that point? Does it have any data type or variable type?
No, because all it is it's exactly like when I typed this stuff out, it just replaces that. It's
so
like
if we
I
wanted
wrote those out myself.
If we wanted that instance variable to be like an array, we would have to make it an empty array, like in the initialize method.
So something like that.
Okay, thank you.
Well, let's say I wanted to make all of those readable. Cool. So now I could do something like, all right, we'll make a car. Hey, car, are you driving? No, I'm not. Fuck that. So I call the drive behavior, and now I'm driving. And if you can do that, that is not a bad place to be with classes and objects right now. So to recap, cookie cutters, blueprints, abstract shapes, all Nissan Altimas. These are classes. Cookies, buildings, concrete shapes, the equilateral triangle with 2-inch sides. My Nissan Altima, those are objects. An object combines state and behavior. States are properties and attributes and that kind of stuff. Variables, behavior, method, function, procedure, those are all behaviors. This is at rest, this is in motion. In Ruby, we required in a class, we just used prize so that we could do stuff with it. This is the method that happens when we call .new on a class to make a new one. We passed in some stuff. You don't have to pass in things. We can just initialize state also. We defined behaviors. We use these macros to read state because we can't read it directly. And that's a healthy intro to classes and objects. Ask me some questions.
Kyle, regarding the cookie cutter cookie metaphor,
yeah,
I have a bit of a problem with that because the cookie itself could be the class, the way we're talking about it the rest of the time here in these other metaphors. The cookie could be the class, and then chocolate chip could be an object, oatmeal raisin could be an object, sugar cookie could be an object.
So, like all metaphors, the cookie cutter one falls apart kind of quickly, actually. But with the thing that you're talking about, it still works. A class might be gingerbread man or gingerbread person. Okay, so this is the class, something that's got this shape. With that cookie cutter, you can make a gingerbread person with sprinkles. You can also have a gingerbread man person that is partially eaten. So that might be its state as like partially eaten and currently has sprinkles. Fuck it, you can make a gendered gingerbread person. It's like, this is a gingerbread boy, this one's a gingerbread girl. Those would be the objects. Evil gingerbread person. But all of them have the same shape. So that's why that's the class and these are objects.
The way I'm thinking of this is that a class is like a Platonic form.
Yes.
And an object is an instance of that form.
Correct. That's good.
And what about the genius-species relationship in terms of biology? Is that also appropriate to think of it that way?
Every single thing in there would be a class.
Gotcha.
So you would have like
like species and then like an individual.
Right.
Or like species.
Sam the tiger.
Right. Ursus, whatever the fuck, that's the class. Yogi Bear is an object.
Right. Okay.
Now that like class, phylum, species, all that kind of stuff, that you'll see that brought up with classes and objects a lot because that's a good way to think of inheritance. Because we can have classes that share things with other classes, but that's for another day.
Okay. Do you recommend the next resource we should look at for classes, a particular video?
A particular video?
or particular lesson?
So let's see. The thing you're trying to do with classes right now is you're trying to initialize some state on an object. You're trying to use those attr readers and writers to make some of it readable and some of it writable and what have you. You're trying to use class variables to keep track of the ones that you make. You're trying to do some calculations based on the state. And then you're trying to make some instances. Don't worry about the Fermi estimate thing. But if you do all those things, that's what you need to be able to do with classes and objects right now. Tools to get there, so many.
Yeah.
Other questions?
Is the attr reader and attr writer, is that specific for the methods, or can that be called once in the?
They're just like you wrote out those methods by hand.
Okay.
Cool. Just like we did the top of this, I want to do a brain dump right now. So I want you to Slack me every single thing you know about classes and objects right now. Go.
Hey, Kyle.
Yes.
I've been working on this whiteboard challenge, deck of cards, and I honestly don't know where I found it. Like somewhere on GitHub and cloned it, and I've been working on it, but I can't find like where that came from.
I'm sorry, I like distracted the shit out of myself. What did you just say? Say that again.
No worries. I've been working on this whiteboard challenge called the
Okay.
deck of cards for
Okay.
the classes,
Mhm.
and I have no idea where I found it.
Oh, it's a classic. That's like
Okay.
a folk song.
But I found it somewhere on Learn Code, like from the Firebase app or something like that, and I can't find it again, like where it came from.
Oh, fuck, man, I couldn't tell you. But like, if you Google like deck of cards OOP, like That is the O Susanna of OOP challenges.
Gotcha. Okay, thank you.
Um,
I kind of worked on it while we were doing this lesson, and I just finished it. Where does that kind of put us or put me?
I don't know.
What should I move on to?
If you can do that assessment, then move on to and you can do the other two also, then I would start scratching at the domain modeling stuff.
Okay.
Cool. All right, pencils down, Slack me, whatever you got. Oh, so much learning happened in the last hour. Good. Very good, Gerald. Magical. Good, very nice. All right, any lingering questions before we break?
That's enough for me right now to absorb.
Everybody's heads hurt. All right, go and be well, everybody.